So this is a topic on circular motion, and in particular we are going to discuss the motion of a car on a circular track in different conditions. So the first case is when a car is going on a circular track. A car is going on a circular track and we want to study what will be the dynamics of this motion. What I mean by that when I say that dynamics of the motion is that we want to see what are the force equations and what will be the maximum velocity allowed on the circular track to a car or to any vehicle. So suppose that this is a circular track with center here at O, and the radius of this circular track is R. And now suppose that our car is going on this circular track with a constant velocity, with a constant speed v, and velocity will be always different because it's changing direction all the time. That's why its velocity will be different all the time, but speed will be same because this is a uniform circular motion. The car is moving on this circular track uniformly. So this is a special case of circular motion, and that is uniform circular motion. We are not talking about non-uniform circular motion, because most of the question that you are going to face in the examination will be from uniform circular motion, and there will be some percentage, 5 to 10% of questions are from non-uniform circular motion. So I am saying that this is so this is a particular special case of circular motion, and that is uniform circular motion. So we are saying that this car is traveling on a circular track with a speed v, constant speed v, and the radius of this track is r, and we say that mass of the car is m. And since we know that this car is, if we draw the free body diagram of this car, so we know that there are the weight is always acting towards the center of earth. This is, we know that all the time this is going to happen, that weight of the car will be towards center, and this is the label surface. This circular track is labeled circle, plain circular track. Labeled means there is no inclination. Labeled circular track. Labeled. I hope that I am spelling it right. So this is normal force that will be acting on this car by the road, and since this car is going on the circular path, that's why there will be a force, centripetal force, and this force has to be supplied by any real force. Like what could this centripetal force be applied by? What real force there could be that can apply this centripetal force? And we know that, however, that our road is rough. A road will be always rough, so we can say that this centripetal force can only be supplied by a frictional force. So the frictional force must be equal to centripetal force. This is the force that can be applied as a centripetal centripetal force Fc, and its value should be mv square by r. And we know that friction force F, we note that this friction force F should be mu times n. And since this car is not skidding on the road, this car relative to road is not slipping in the direction of friction, that's why this friction is static friction. So this is the force applied by the road on the car, mu s into n. And we know that this is the maximum value of the force that could be applied by the road. So Fc, the centripetal force, must be always less than or equal to this maximum frictional force, and we can write it like mv square by r, and this should be less than mu s into n. And n from this free body diagram we know that n is equal to weight of the car or weight of the vehicle, mu s mg. So from this we find that velocity should be always less than or equal to mu s into rg. So the maximum velocity on a circular track, what is mu s r g. All these values mu s, r and g are constant for any given road. So the value of mu s will fix for a road, and whatever is the vehicle that is going, the tire of that vehicle, so mu s will be fixed for that vehicle, and a radius will be fixed for the circular track, and g, we know that this is the fixed quantity. So that's why the maximum velocity for any circular track, it's become fixed. This is the maximum velocity that can be attained by any vehicle. I mean, it can differ for different vehicle depending on the value of mu s. So for some vehicle mu s will be different, because mu s is the property of the surfaces in contact. So this is the maximum velocity that is allowed on this circular track. And whenever the vehicle try to goes beyond this velocity, there will be skidding. What will happen, the vehicle will skid outside the road. So it will skid or slip outside the road. So this is the maximum velocity allowed. So we see that there is not a lot of room to gain velocity. So what we can do is that we can make a slope. So now we take, what we do, that we bank our road. What do we mean by banking is that we lift our roads not on a very great angle. Must say that our road is like this, and at some angle we bank our road. Now our vehicle is going on this banked road. So we are talking about banking of the road. What do we mean by banking? Banking of the road means that we just raise one side of the outer side of the road is just little bit raised, so that there is a slope on the road on this track. We know that radius of this slope, this circular track is still r, mass is mg, mass is m. So this weight, if we draw the free body diagram, its weight will be downward mg, and the normal force will act like this. And these are the only two forces right now that we can see. And we know that to move in the circular path, there must be a force Fc. So we are saying that we can draw the free body diagram of the car like this. Mass of the vehicle is m, normal force is acting perpendicular to this bank, radius is r, and this is how this will be its free body diagram. And we know that this angle is theta. By experience we know that, we have solved so many questions that we know that angle is theta. So we can say that this angle will also be theta. This will be 90 minus theta, so this will be theta, not this. So we can say that the acceleration or the centripetal force Fc, that should be mv square by r, and that could be applied only by this normal force. If we resolve the normal force along the direction of center, so it will be n sin theta is equal to, it should be mv square by r. This is along the center, towards center, and n cos theta will be equal to, this will be n cos theta in this direction, and this would be equal to mg. So from these two equations we can say that if we divide equation 1 by equation 2, then we get tan theta is equal to v square by r g. So from this equation we get v square is equal to rg tan theta. So velocity v will be root rg tan theta, and this is also very fixed quantity. So even on the banked road, when we bank the road, there is still, this is the maximum velocity that is applied by that is because of the normal force. This is the maximum velocity that can be attained on this, that is allowed on this road. If also if you see that r is fixed, g is fixed, and tan theta, angle theta for a road is fixed, you cannot change slope of the road all the time. On your need you cannot just change. So this become fixed. So maximum velocity allowed even with the bank is also, it's become fixed. So this is the maximum velocity that you can get for any vehicle on a banked road. So I mean we know that tan theta we can have values of, although angles are not, roads are not like 50-degree and 60-degree angle, so roads are mostly aligned. So angle of these roads are usually 5 degree and 10 degrees. So it's not very great angle, that perceptible angle that you can see that there is slant height, there is banking of the road. So these roads are very labeled mostly. I mean, there is no perceptible sloping of the roads. And the third case is banking of the road. Is we are now seeing, we are still on the banking of roads. So what we are saying, that we do not get sufficient velocity on the level road. So what do? We bank our road. So we raise the other side of the road a little by a small angle. Normally this is done to gain some more velocity. You will see how. So this is our road, and this is angle theta, this is radius, our center is somewhere here, this is radius r, and this is our car or vehicle, and this is going with the velocity v. So this would certainly need a centripetal acceleration v square by r. We know that normal force is always perpendicular to the surface. So this is normal force. Weight mg will be always acting on the ground, towards ground. So what will happen, that we have just calculated that on this bank road the velocity v is equal to rg tan theta. On this velocity the normal force will be sufficient to provide this much velocity. The normal force, the component of normal force is sufficient to provide this much velocity, and there is no need of friction to come into picture. But what happens, that when our velocity goes on increasing beyond this velocity, now suppose that our vehicle is speeding up on this track beyond this velocity, so angle is fixed, g is fixed, so the car has to go on a bigger radius, on a wider track. So what will happen, that our car will try to go in this direction, outside of track. So our car will try to go in this direction. So that's why a friction will come into picture, and this will start to act on this. And we can think of in this same situation, if our velocity from this value, if our velocity goes on reducing, what will happen? So from this value, if our velocity is keep on decreasing, so start to decrease, So what will happen, g tan theta will remain same for the fixed road. So the car has to move on a smaller radius. So what will do, the car will try to come around this side, so what will happen, that the friction force start to act in the upward direction. So these are the two cases when speeding up. So what is the maximum velocity, what is the v maximum that is allowed on this track before this vehicle skid, or what is the, if we start to speeding down, if we start to reduce the velocity, speeding down, v minimum, what is the minimum velocity allowed on this track. So this will be two cases. If velocity is rg tan theta on this banked road, there is no need of friction to act on this vehicle. But if our velocity, our vehicle start to speed up, then friction will act in this direction, in the opposite direction, because once car is speeding up, it has to go, this is the radius is only variable, this is can only vary, so this has to go into bigger circle or bigger wider track, and so the car will go up. So for that, at least it will try to go up, so the friction will oppose this motion. And when car is speeding down, so radius has to decrease, and when radius has to decrease, then the car will come around this corner, and that's why the friction force will be acting on, start to act in the upward direction. So we'll draw the free body diagram of first case when speeding up, vehicle is speeding up. So what will happen, that normal weight will act downward always, and the normal force will act perpendicular to the plane, that is also always true. And the since it's speeding up, friction force start to act in this direction, and we need a centripetal acceleration, centripetal force mv square by r. So we can break this force on this axis and this axis, we can break on this axis. So we can say this is, if our inclination is theta, then this will also be theta, this will be theta, and this will be theta. So we can write the equation. We are saying that the force on the vertical line will be n cos theta, frictional force will be fs sin theta, and weight will be always acting on the towards center of the earth, or you can say mg downward, and in this direction there are forces that are n sin theta and frictional force fs cos theta. These are the only forces that are available, and we have resolved them. So now we can write the equation that should be n cos theta minus fs sin theta, and that should be equal to mg, Newton's law for the vertical axis. And for this horizontal axis, it should be n sin theta plus fs cos theta, and this should be equal to mv square by r, This is equation 1, this is equation 2, and from these equation we have to find out velocity v, and we can see that we also know that fs is always mu s into n. So wherever there is fs, we can just replace it by mu s into n, and we are also dividing 2 by 1. We are doing dividing equation 2 by 1. So this will become n sin theta. Next time when I will re-record this video, I'll try to make it more clean, because I know that this is a very rough kind of video, and also I'm also not very good at creating YouTube. These are my, you can see, you can understand, these are my very first, instead I could say that I'm just starting at YouTube and I am learning to how to record, and this is very difficult for me because I'm not very good at this, because I'm very new at this thing. Hopefully this should be very clear. And after solving this, we see that v square by rg is equal to tan theta plus mu s. What I was doing, that I was skipping a step. So from this we can write that v should be rg, and we divide both equation by cos theta. Numerator and denominator, what do? We are dividing cos theta. So this will become rg tan theta plus mu s divided by 1 minus mu s tan theta, and this will be under the root. So as you can see that this is the maximum velocity that is allowed for a road. Theta is fixed, mu s is fixed, so everything is fixed. So this is the maximum velocity at which our car or our vehicle will not skid. So we started with this. We started our question was that on an inclined or on a banked road, if a vehicle is traveling with the velocity rg tan theta, so there is no need of any friction, but they start to speed up. This is, we have started, our vehicle is starting to speed up, so this has to go into bigger circle, and for that radius has to increase, and so car will start to go up other side of the road to increase this radius. So friction will start to act down the inclined plane or down the road. So we get that the maximum velocity because of friction that we can get on this road is rg tan theta plus mu s divided by 1 minus mu s tan theta. And even if we want to go beyond this velocity, then our car I mean, this is the maximum that friction can apply this force to stop from skidding. So if you go beyond this velocity, the car or the vehicle will skid. Even from this equation, if we say that the friction is not there, so mu s will be 0, so rg into 1 tan theta, you can see that this is same thing. Now what we are saying, that what will happen if the car is or the vehicle is speeding down. So our road is like this is our banked road, and our vehicle is going on this road, and we have found out that if the speed of the vehicle is rg tan theta, then there is no need of any friction. But our vehicle is speeding down, so our vehicle is slowing down below this velocity, so the vehicle start to come down on this plane or on this road. So radius has to decrease, and so this will start to come down. So the friction will start to act. Friction will act upward on this direction. Friction will start to act. Normal, like always, normal will be along this direction. Weight will be acting like this, and this is, so the free body diagram says if inclination is theta, then this angle will also be theta. We know that from experience, and we can draw it like this, so this will be angle theta, this will be angle, this is angle theta. So the free body diagram of this car is that friction force is acting up the inclined plane. Normal force is perpendicular to this incline, and weight mg is acting downward, and we can break all these forces on these two lines. This angle is theta, this is theta, this is theta. So we have resolved these forces, and we are writing it on this direction. That should be n cos theta, and because of frictional force, the force will be f sin theta. Weight always will be acting downward towards center of the earth, and there are other two forces that are acting. This is f cos theta, and this is n sin theta. So we can write down the Newton's law of forces. So we can write down these forces. That should be on the vertical direction, it should be n cos theta plus fs sin theta and this should be equal to weight of the vehicle, and the other equation will be n sin theta minus fs cos theta, and this is the force that is responsible for centripetal force, mv square by r. We can say that this is equation 1, this is equation 2. and after dividing equation 1 by this equation 2 by 1, not by 1 but equation 2 by 1, this is operation we are doing. So we can, and we also know that this friction Fs is always mu s into n. So wherever there is Fs, we will write mu s into n. So we are dividing also, so this will become n sine theta minus mu s n cos theta is equal to mv square by r, and we are dividing this by n cos theta plus mu s n sin theta divided by mg. So from this equation we see that v square by rg equal to cancel out n from the numerator and denominator and divide numerator and denominator by cos theta. So we'll get tan theta minus mu s 1 plus mu s tan theta. So from this we see that our velocity should be rg tan theta minus mu s divided by 1 plus mu s tan theta. So this is the minimum velocity that is allowed on this road before so this is the minimum velocity that you can attain before your vehicle to slip on the road. So we have seen that the allowed velocity, we have found this, that allowed velocity before skidding, what is that? That is v naught is equal to rg tan theta. If you keep this velocity on the inclined plane, then there is no need of friction and there will be low wear and tear in your vehicle, in vehicle's tire. This is what is written in the NCERT, that this is the optimum velocity on the bank road, and we see that minimum velocity before skidding is rg tan theta minus mu s divided by 1 plus mu s tan theta. This is the minimum velocity that is allowed on this banked road before it start to skid. So we can have this velocity minimum, we can go up to this velocity before our vehicle start to skid, and the maximum velocity. So these are the allowed velocity on a banked road before our car start to, or our vehicle start to skid. You can see that this is, you don't have to remember this. If you solve NCERT HC Verma, then I have seen that there are two to three questions on this formula only. I hope that this clears some, I hope that this gives you idea that how to solve these kinds of questions. You don't have to remember this formula because your mind will be already saturated by too many information, so you don't need to remember this. You can only learn this procedure, that how we can find these equations.